Thank you so much for coming back to our channel. Please make sure you subscribe to get updates every time I upload a new video.
This lesson, we're going to discuss about the covalent bond, or sometimes you can pronounce covalent bond. Anyway, I like to say it as covalent. Now, covalent bonds occur when nonmetals combine through electron sharing. This is the second way that chemical bonds can be formed, through electron sharing. For example, the formation of hydrogen molecule. Hydrogen atoms can be drawn using the following methods. You can use a dot or a cross. Now let us use a dot for one and a cross for another to represent electrons. Now when two hydrogen atoms combine with each other, they do not really transfer the electron from one atom to another. But still, they could share the electrons in order to obtain the stable configuration as follows. As you can see, the energy levels will overlap and the electrons will be shared between the two atoms. So this shared pair of electrons forms what we call a covalent bond. This observation was made by a scientist known as J. N. Lewis in 1916, because he noticed that some compounds do not really transfer their electrons from one atom to another, but rather decide to share the electrons. We can represent the covalent bond in different ways. The first one is here, that I have circled in orange. The one dash or hyphen represents one covalent bond, meaning a covalent bond formed by sharing of two electrons, one from one atom and the other from the other atom. The next example is the formation of chlorine molecule. Now, each chlorine molecule has 7 electrons in the outermost energy level. It requires only 1 electron to obtain stable configuration. But in this case, instead of gaining 1 electron, the two atoms decide to share the electrons. And when they share the electrons, they each obtain a configuration that is stable, as follows. So the shared electrons that are located in this position can move around any of the atoms. But generally, each atom now has a stable configuration because they have shared their electrons. So we could count these as 1, 2, 3, 4, 5, 6, 7, 8. So it has an octet state or an octet configuration. For the second one again, still on the same way, we say 1, 2, 3, 4, 5, 6, 7, 8. So they both satisfy the octet configuration. Again, to represent, we use a single line, or we could just write the chemical symbols and a dot and a cross between them to represent the chemical bond. The next example is the formation of oxygen molecule. Now, for oxygen molecule, let us just ignore all the other energy levels and consider the outermost energy level. So the first circle represents the nucleus, And this one now is the outermost energy level. Now, in this case, oxygen requires 2 electrons to obtain a stable octet configuration. Now, each oxygen atom donates 2 electrons for sharing, and they form 2 covalent bonds between them. And we draw them like this. Now, in order to represent this, we use 2 lines. Each line representing a covalent bond. Again, we could use the dots and cross between the symbols of the element. For the next example, you can call example 4, is the formation of ammonia molecule. Ammonia is written as NH3. You can see it here, NH3. Meaning 1 nitrogen has combined with 3 hydrogen atoms. Now we are only considering the outermost energy levels in this case. So 1 nitrogen and 3 hydrogen atoms. Now nitrogen requires 3 electrons to obtain a stable configuration, while hydrogen requires 1 extra electron to obtain a stable configuration. So 3 atoms of hydrogen would share electrons with nitrogen to obtain stable configurations as follows. As you can see, now the dot represents the electron from hydrogen and the cross represents the electron from nitrogen. So here we have 1 electron from hydrogen and 1 from nitrogen to form a single covalent bond. The same here, same here. In the end, for hydrogen, it has 1, 2 electrons. Same for this one, same for this one. Now for nitrogen, it has 8 because we have 1, 2, 3, 4, 5, 6, 7, 8. So they all satisfy the stable configurations. In order to represent this in a short way, we can use the single line that represents the bond, a single covalent bond formed from a pair of electrons. Now we have to write the extra 2 electrons here so that we can be able to represent and notify that we have 2 extra electrons that have not participated in bonding.
Remember to share this video with friends and tell them it's actually free to subscribe to this channel.